So hello guys, in today's video we'll be solving the question maximum width of a binary tree which is on leetcode. Let's get straight on the question. And guys, my face would be here cause my desktop and my monitor is here but my camera is here, so I hope this doesn't bother you guys. Coming on to the question, first let me give you the clear picture of what the question actually is, and let me explain you what the question is. Given the root of a binary tree, return the maximum width of the given tree. The maximum width of a tree is the maximum width among all levels. So, do you get the idea what the question is? I'll just break it down. Yeah. So basically, the question is that you are given a tree and you have to tell the maximum width between the two nodes which are at the maximum level, like the at most left and at most right. Okay, now from here what can you say, like what is the width of this binary tree? It's 1, and then 2, then 3, then 4, then 5 or 6. But now actually the maximum width of a binary tree, when we take it in such a way that it's a perfectly complete binary tree. What I mean by that is we have to create a node first here. Okay, then we gotta create a node here, then we'll create basically another node. Okay, now and now this, and now it's still not over guys, like yeah, it's still not over. Just ignore my drawing guys. Yeah, and now yeah. So first the tree which was given to us in the question, uh like did you saw the tree, like the tree which was given first? It was kind of this. I'm so sorry for my drawing guys. Now this and this, like it was just a triangular tree, right? Okay, just ignore this guys. I know I drew it very bad. Yeah. But now coming on to the question first, what I gotta explain you right now here is, now if you can see what is the maximum width of the binary tree right now, it's uh it's 1, then 2. I'll do like yeah, 1 1 1 2 3 4 5 6 7. Okay, nah, here's one more. So 1 plus 1, 2, 3, 4, 5, 6, 7, 8. 8 is the maximum width. But how are we going to get this? So what the regular approach says, like what's the approach which comes in your mind right now in the first place? First is BFS, like we do breadth first search. We go from here, then here, then here, then here, right? But who will write that BFS code of Q and all? I mean, instead, can we apply a DFS? Is there a is there any idea? Like, is there a way we can apply a DFS? Then yeah, we have a way. But first of all, we have to iterate from one node to the other, then we have to go to the last. Like what I'm saying is 1, now this is 2, now this is 3, now this is 4, now this is 5, 6, now this is 7, now this one is 8, now this is 9, 10, 11, 12, 13, 14 and 15. Okay, so basically the answer here is 15 minus 8 plus 1, which gives you the answer of 8. But can you see a pattern? Can you see here? 1, 2, 4, 8. 1, 2, 4, 8. What is this? This is basically, this is nothing. This is 2 of, uh, wait, yeah, I hope you get it. This is 2 of I, because here the index is getting multiplied by 2 into 2 into 2, right? And now here, what is the relation here? It is 2I plus 1. That's it. That's the question, guys. I mean, 1, 3, then 7, then it's 15. And now what we have to do is we have to go to the leftmost node. From the leftmost node, we have to go there. We have to need its index, which is basically 8. We need its index, and we have to go to the rightmost. To the rightmost node, we want this guy's index, which is 15, and we do 15 minus 8 plus 1. And now what we'll do is we'll use a hash map to store the first positions, this guys, to store these guys. Like, on every depth we'll store the first position, and we don't have to create this thing, it can be ignored. Like, if you ignore it, I know this is very dirty. Wait a second. Yeah, what I'm saying is we'll only store in the hash map the first position of this, and we'll subtract it from this part, this guy, and this guy. At every depth, this will be minus from this will be done from this will be done from this, and we'll go till it's null. Okay, so now let's code it. I hope I gave you one example and how it will be done. So let's go to the compiler and just let's code this. Yeah, so first of all, first we'll do is what? We'll take the width as 0. Then we'll make a hash map. Basically, we create a dictionary in Python. I'm actually coding in Python right now. So yeah, and wait a minute. Right now, I'm looking here. So I think I should just close my camera once again. Yeah. So yeah, now this is first position, and this is, we'll create a hash map here. I hope I'm audible too. Now we'll uh, now we'll just write the condition. If not, wait, yeah, we'll create DFS in which we want node, comma, depth, and the position. Okay. And if depth, basically we are in this thing which I'm writing right now. If depth not in first underscore position is basically, we are going to the every next level. Like, we are going into the, yeah, the hash map which I created, the dictionary basically which I created. In that, what I am saying is, yeah, now what I'm saying in this is, we are going in in the hash map. I'm storing this guy, then I'm storing this guy, and then I'm storing this guy, and I'll subtract it from, this guy is subtracted from this guy is subtracted from this guy is subtracted from this, and of course we do plus 1 in every case. And at every depth, at every step of the recursion, we we calculate the distance between the two leftmost and the rightmost node. the hash map which I created, first underscore pos, is basically telling about the first position we are getting into the hash map. And you can also say the leftmost. Okay. Yeah. And if depth not in first underscore position, then what we'll do is first underscore position, at that depth we'll create the position. Okay. And now what we'll do is we'll basically take the max of self dot width, comma, we subtracted from position, which will be the rightmost position. Basically in a tree, I mean, it will be the position on which we are traversing, like this position, then this position, then this position, then this. Of course, in a tree, if there is this node, then we are also traveling here also, right? Here, so sorry guys, in this we are only subtracting these position from these position, because of the position will define in the DFS, because we'll go from 2i plus 1 and we'll do 2i. So basically we are subtracting the leftmost and the rightmost pair. That's the only the question, that's the crux of this question. So we'll do set minus first underscore position, then we'll do plus 1. Yeah. Now we'll write the basic code of the DFS. We'll call the DFS. We'll call that guy. Yeah, we're traversing the left and we are going down, and at the left side, what relation did we had? We had was 2 into position, right? Yeah. Now DFS is a node dot right comma depth plus 1, 2 into position plus 1. That's the call. Will call it root, start from the 0 index. One thing, guys. So yeah, actually my code has couple of bugs and error, which I'll just make sure that doesn't happen again and again. And this is the code. Okay. So what we did is, I'll just give a quick recap. We wanted the maximum width, so uh, we made width 0. We made a hash map to store the leftmost and the rightmost guy, and we'll take the difference of that, and plus 1 is basically the maximum width. Then we'll do the basic DFS in this, and we'll put the basic condition. And if we are going on to the depth for the first time, like in every depth we take the leftmost guy, so basically the first position we take in at every level of the depth, and then we subtract it from the position from the rightmost guy and we traverse it, and this is the code, and I hope you get it. So yeah, thank you, bye.